All right, so there we are. We're recording that, and I'll share my screen out. Okie dokie. So here we are. Here we are again. At least for the next 2 weeks, and I think everyone probably figured that out by now. The we're gonna have to deal with this. So a few things here. Today's class was set aside or meant to be for, um, you know, um, whatchamacallit, to do our lab, right? Now, everyone hopefully has their kit. If you don't have your kit, let me know. I will have someone from IT run it over to you. For example, I had a person, they moved, so they had to go from McReynolds to Whitney, and so the wireless wasn't working. I put in a ticket, and immediately IT ran over there and gave me Ethernet cable because the Wi-Fi wasn't working. So whatever you need, that should never be an issue. Um, let me know, sooner than later, and we'll get you what you need. Because the reality is that after Thanksgiving anyway, it's already planned that we go all remote. So if we're going all remote, that means that you have to have something working, a system working for doing your labs, not only doing your labs, but really doing your final project. Because what you'll find is your final project is going to take like a month, and it is because it's kind of a big thing. So you need to be able to have a kit, have the software on your computer, whatever that might be, if it's a desktop, if it's a laptop, whatever it is, you need to get this set up. So, okay, so now that that's out of the way, any questions with what we have to do? I mean, in the long run, not today. No, everybody's cool. Okay, good deal. Okay, so what are we gonna do today? Well, like I had said before, the big thing with this, it's not so much about like, hey, do I got 100% how to wire this up? Like, we should have a pretty general idea on how this stuff works. So what I can do is, because if you recall, on last Thursday, yeah, today's Thursday. Last Thursday, we went through and we set up that whole button thing. So we could push a button on here, and then we would have a delay on the amount of time the LED turned on. Well, in some of you, the furthest you got was just being able to push a button and it would turn on. All you had to do then was build in the actual delay. That is the programming component of the course. If you have the electronic stuff set up, like I can control with a button, again, all you have to do is read the button state and then delay it based on what you put that in there. Oh, you have to actually hard code a delay, like 7.5 seconds or something, right? So we saw that last time. So the goal today would be, I'm just going to wire up what is one possible way that you can do module 2 lab. So that's this one right here, right? Control the amount of time between when an LED flashes. So the amount of time will be adjustable based on a potentiometer. The range should be from a starting position of 0 or always on, no delay, through a 5-second delay. The 5-second delay should always be for the amount of time the LED is off, and a constant 1-second delay should be set for when it turns on. Well, and again, except for when it's set to 0 where there's no delay. And then you have to do all this other baloney, which we already did before. Okay. So like I said, what I want to do is I want to wire this up so I can show you what it looks like, and then I'll actually go through and show you it working, so you know that it is possible. And then we'll talk a little bit about how you can make that work. And then ultimately the goal would be for you to work on it and do it yourself, right? For some of you, we may need to work, well, I'll talk about that later. But at any rate, we'll talk about that after we go through this. Okay, so how are we going to get this working, gang? Well, as we can see here, I got this as a pointer. Will this work? Yeah, this will work. So we said we need a control mechanism, right? We need some way to be able to adjust the delay here. So you can see what I have. I have, this side, the flat side of my potentiometer. One side's just going into 5 volts. The other side's going into ground. So I'll have, some adjustable value here. That adjustable value, again, will be from 0 to 1023. And then you can see I have this wire coming out, and that is going to go into one of my analog inputs, right? So that's going to go, in my case, I have it in A5. Okay. So you can think, all right, with this, the way that this circuit is currently set up, I have a way that I can read in this value here and determine what the number is. And that number is supposed to control the delay in the amount of time that the LED is on. I'm sorry, is it on or off? Let me go back and look at my instructions. It should always be for the amount, it's off. So 1 to 5 seconds that it's off. So again, this is going to be my control. This is my input. This is what I care about. Now the rest of this to wire up for the LED is not that bad. So let's go do that real quick. Okay. Here's a good question. As I'm wiring this up, do I need to worry about what type of digital pin that I'm using here? Should I be concerned with it being in one of those GPIOs that support the analog or the simulated analog? Do I need to worry about that? Okay, well, you can use that, but truth of the matter is, I only really need to just turn it on and off. If I only need to turn it on and off and the delay is actually being controlled by my potentiometer, the answer is I don't. I can plug it into anything. I don't need the squiggly line because I'm not trying to simulate. I'm not doing any sort of pulse width modulation. You could and make your circuit a little bit more complex, but we actually don't need to. So let's wire up the LED for us. Yeah, where are my LEDs? I have to use my spare kit, and unfortunately my spare kit ends up being all over the house. There's a green one. Oh, let's use yellow. Okay. So now let's plug this guy in, and I might as well just pull off the ground to here. And then I just got to worry about my positive. But we said we have to put a 220 ohm resistor in series there, which where are those at? Oh, Nelly. Oh, her. Great. Well, I'm going to have to use these. Okay. Now we'll put this in the positive side here. My anode end of my LED, like so. All right, come on, get in there. See, I don't have a lot of room on here. That's because, again, both of my good breadboards are in my office or in the lab. And I'm not there today. Okay, so let's hope that that works. All right, now you just see I'm building it. I have my ground connected to the ground side of my potentiometer that then goes into these two. These are your 100 ohm resistors. This should be enough not to fry this thing. Ideally, I should put on a third one. We'll just see if we burn it up, whatever. I don't care. Now this side, the positive side, where's that guy going to go? You can get the camera closer. Yeah. Here's what I can do. Yeah, Hey, that's better than the lab, isn't it? Although I think it's trying to focus on this and not the other stuff, because that's why this is fuzzy. So what I can do is just put a solid color behind it. Let's see. All right. There's something. Well, dark would probably be okay. Well, that did not help at all, but whatever. At least we get a better idea. I can tell you what everything is. You know, why is that just so out of focus here? But at any rate, what I have over here is my LED. The one side, the flat side, the negative side is connected to the same wire that goes to ground, which is this blue wire. So that's one side of the LED. Why is that so bad, out of focus? Because it's too close? Yeah. It just does not want to focus on that. I don't know why. Just for me to see that, that's like really hard to see. Why is that not going into focus? But anyway, you have to trust me. Positive side, I'm not tying my LED into the positive side of the potentiometer at all, because that's what all this stuff is for. So these resistors going out here. Wait. Oh, okay. Good. Well, here I can to this so it's a little bit closer. All my low-tech equipment I have in my house. Okay, so then positive side, right? The positive side of my LED is going through one resistor, and all you have to do is put in that, what is it, 220? Yeah, 220 ohm resistor. I have two because these are 100. So that's why they're in series together. So then I'm going to pull this side off of here, and I'm going to go into one of my digital pins on this side. That digital pin on that side, I'm going to send a high value. I'm going to send a high voltage to it. Again, based on the input of this guy, this orange wire. And that's pretty much it. So let's do that, and let's see how it works. All right. So we'll go here, and I'll just pick a random, I'll use 8, pin 8. A bit interesting. Okay, so now we're good. Now, all we'll need to do is fire up our fire up this guy. And then I'm going to put some code in there. Oh, gee whiz, I probably should plug it in. And since I have no idea what any of these values are, I mean, I'm really not going to hurt this circuit, but again, it's good practice just to zero it out so that way I know that I'm not writing an input, you know, doing all any kind of weird stuff. I should really, oh, it's too late now. Just write out a blank here. Okay. Hope everything's good. Yeah, that's what I thought. Okay, so let me come on. Why don't you want me, why won't you select that? There it goes. Okay, so it looks like it skipped for me. All right. Oh yeah, because this is actually a new board. So good. All right, so I got that in there. Now let us do a couple changes here. 8 and 5 and okay. So let's upload this guy. And it looks like some beep, 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 beep. Okay, so it looks like it's always on there, right? It's always on. So then what I should be able to do, hopefully, is turn that. So I turned it all the way. So I turned it all the way to the highest setting, and it should be 5 seconds. And remember, it's only on for 1 second. Okay, so that again is off for 5, on for 1. 1, 2, 3, 4, 5, boom. Right. So then maybe I go about halfway there. If I go about halfway, let's just make sure I got it halfway. Right here. Halfway. 1, 2.5, 1, 2.5, right? So that's what you want to do. And then you said, and we said that, well, if we turn it all the way down to 0 or always on, we should be able to just have it all the way turned on. Now, you'll notice, right, there's a delay in the amount of time that it in essence reads from this potentiometer, right? Because I don't have, it's not like an immediate, you know, oh, hey, wait for it. I don't expect this to be that sensitive. It's just a matter of, I want to be able to control this. So I'm going to turn it all the way back up to 5, right? So then it'll be off for 5 seconds, on for 1. And that's the lab right here. This is lab 2, wired up exactly like this. And well, not exactly, you'd want to just use one resistor, but otherwise everything is there. Now, we have to have a conversation about how do we make that work, right? So I'm obviously not going to give you the sketch because that would be silly. Then you just what? Amount of brain power is very negligible at that point. So again, somebody's making calls. Oh, that was Harry. Thanks, bro. Okay. So let's just go over all this, like from start to finish again. Well, unless you guys have, what do you have specific questions about? Because, you know, I kind of already stepped through everything. What do you want to see or what do you want to know about? Like how this works? The code? Yeah, right, dude. You can't have it. No. You know, I mean, what you don't want to do is just like with the other courses, you don't want to go online and go find something. Like there probably is. I don't know. This is a pretty kind of unique scenario, but I mean, you could probably Google like control LED with potentiometer Adreno, and maybe you could find something. But again, that is like super lame, right? It's super lame in multiple respects. What'll happen is you'll just get used to that, and you'll be looking at all the labs, right? And then all of a sudden, you have to do your final project, and your final project is one of two things: either it's a ripoff from online, which I'm actually okay with doing. I will talk more about that. But then it also it could just suck too. Okay, so let's see. Ben, do you have the LED in the two holes with the potentiometer? Yeah, good question. Because it looks like it, right? If I'm looking at this, it looks like that LED is just in this. What we said is that we only are pulling from the negative or the ground side of the potentiometer. And because that is this blue wire that goes into ground. So I have my blue wire that goes into ground that also goes to both the potentiometer and the cathode end of the LED. The anode end, and again, it's a little bit hard to see, but it's right down here. That anode end goes through that resistor, then it goes through this resistor, and then that wire goes all the way over to digital pin 8 in my case. You can make it whatever you want. Digital pin 8 controls the high and low value, like turn it on or turn it off. What you have to figure out is, how do I take this value that gets read in from this orange cable that's on A5? How do I change that to be the amount of time that this guy is delayed? And I will give you a clue. Again, I'm not going to give you the code, but I will give you a clue. You will need to, or you will want to, use the map function that we talked about, and you'll also want to use the delay function, right? Because think about it. We've always said we would just delay, and we hard-coded some constant integer value here. Well, why can't I say something like delay, and then that constant integer value is a variable, and that variable is the amount of time that I pause? And in fact, that's exactly what you want to do, or that's one solution. Okay, so yeah. So the map stuff, right? Remember, it's back here. If I go here, functions. And that's one of the last ones, yeah. And that's definitely one of the harder ones, right? I mean, this is not easy stuff to digest here. And in this case, when we say map, right? What we said was we could take this value, and that value is going to be really from my pot, right? Because the pot value we know goes from 0 to 1023. So what you can do, it's going to be 0. What we want to do is we want to take 0, and that would be a delay of 0, right? We would want that to be delay of 0. But then what's our upper bound? What's the maximum amount of time that we want our LED off for? I know. I threw out there that in the 255, you're right. That's what we looked at. But that was when we were talking about pulse width modulation and how we wanted to flicker, right? Like I said, that is one route you can go, but you would have to guess on how long that 5-second interval is. Like, well, no, I'm sorry. That's for dimming an LED. What we're doing here is we're not dimming the LED. So yeah, I could see where you would think, yeah, 255. But again, what's the maximum value that I want to get it to? I want to start at 0 or a delay of 0 seconds. What is the maximum delay that I want? If it's not 255, think of it in time. I know it's almost easier what we're doing here than what we looked at as an example in class, and it is. So our upper bound value, it should be, again, if it's a delay and we're talking time, it should go from 0 seconds or always on or always high, really, right? Always high to this value, which is going to be 5 seconds, right? So now if I take the from low value of 0, I take the from high value 1023, because I know what those are. Too low, too high, well, I just put in a delay of 0 seconds and a delay of 5 seconds. And I'm using a unit here, and there's a reason for that. And you'll see why if yours isn't working. And I will help you out with that. Okay, so that's everything you need to know. I mean, obviously, you need to know how to turn on an LED. You need to know how to read input from an analog. You know, you need to know how to read this. You need to know how to take this value that this orange wire's on and take that and use it. I said make it a variable, right? So whatever value I'm reading in with 85 in this example, I'm going to use that as a variable. And then that variable is going to use, I'm going to feed that in for the value of my map function. Okay, so let's work on that. We have 50 minutes, so that's a lot of time. Now, again, if even if you don't have the Adreno IDE installed on your computer, you can at least get this wired up. Or you may be like, I'm still trying to work on the delay for lab 1. Given the fact that I am obviously not there physically to help you guys, you will want to get a camera. I mean, and hopefully if you don't have a camera, you could join a team meeting with the phone. Some people have used that, and then just took their phone and just held it over what they're working on. Or in a lot of cases, people will hold it toward the computer screen to show what they're looking on if they can't share their screen. If they're using a Mac, for example, on the web team connect, the desktop app. But my point is that we will take some extra time. I'm not going to make this assigned and due on Monday. I think it's a little unfair because I'm not there to help you. So I'm going to kick the can on this assignment at least by probably a week. And then you guys will have this due the following week. That doesn't mean that you can just, brush your hands clean. You don't have to worry about it for a week. No, what it means is that next week you need to set up a time to meet with me and get some kind of system in place. So, you can do this working on, and I can help what that looks like. So that's that. Sorry, I have a cold, and it's a cold. I'm trying to mute it if I can, but at any rate, hopefully it's just a cold. I mean, I've had it for I think 1 day. I don't have a fever. The other COVID symptoms, hopefully, I'm okay. But at any rate, virtual breadboard. Oh, look at this. What's this you got, Devin? Wow. Your presentation ended. Someone else started sharing. Okay. Um, yeah, let's see what you got. Look at this beauty.
Yeah, I was just thinking of this as maybe instead of doing the whole camera thing, they could use this. If they wanted to show you what they're doing.
Yes, this is definitely clutch, man. I hope you don't mind. I'll give you credit. I'll say
It's
that
free too, so.
this is fantastic. I am loving this, man. Ooh, look, there's even an app for it. Get it
Yeah,
from
that's through
Microsoft.
Microsoft. Yeah.
Yeah, I will even pay for that. I mean, that is so
It's
awesome.
free. I'm sure there's probably a better version that has more stuff, but it looks like the free version has everything we probably need. Like here's an LED stuff,
Wow.
buttons.
Get it. I am getting it now. Open Microsoft Store. Add that to my account. Man, that is fantastic. I'm telling you, this is a game changer because, I mean, I could show this physical stuff all day long, but I think it's hard to see. Like if you have like something like this is wow. This is great, man. So thank you so much. I mean, I didn't even think about like something like this, but this is just going to make life so much easier. Um, yeah, and I think you're going to get a better understanding. I mean, it's the same exact breadboard even that we have. I think except the rails on this don't all connect. It looks like the outside. So just be
Mm-hmm.
mindful of that. Okay, cool. Well, then, yeah. So if you don't have, like, you don't have the capabilities right now, I mean, you can do the virtual breadboard and get that set up, right? And then again, like I said, email me if you have any problems or questions and stuff. Okay, so let's all work. And at a minimum, well, if you don't have Windows, you can always remote into the computer at in class. You can remote in there, add the virtual breadboard on your account. You'll have to sign into Microsoft. Use your Defiance account to do that, and you'll have to decide if you're going to use the school or personal. Remember that you always want to use the school or the organization, and then that school or organization has a different password than you use to log into your Gmail or your Google account, right? And again, if you have any questions about that, let me know. Um, but again, today we just want to work on this. Um, let me know what you need, questions you have. We can, if you don't feel comfortable sharing your code that you're working on, we can break into an individual team or something like that, or just do a different meeting. Let me know what you need. You can just chat with me too to let me know you want to set up something and we can work it out. So let me know what you need. All right, guys. And I'm going to go on mute so you don't have to hear me hacking.
Is there a way in the virtual one to make the LED, uh, and different like move the prongs on it?
I don't know. I'm on a metered connection right now, and it looks like I don't know what setting I need to change to make it so you can download over a metered connection because I'm on my cell phone. So I can't download it right now. But Devin, I don't know. Can you help him out? And then Michaela, what was the thing we had to say in setup? Right here, I could share my screen real quick.
Yeah, I'm looking at
Yeah.
that later now. I'm just gonna take a look at it.
All right. Let me share my screen. There's something that I could use. I think it's right here. Yeah. It's this, Michaela. Remember, it's a class serial.begin, and that serial.begin needs to match. I could just share my screen here. Yeah, so then it has to match whatever the communication rate is of this guy. So down here, that's why we say serial.begin 9600, because that's the default value.
Actually, can you double check that this is right? If you can see.
Yeah, I can see it. Okay, yeah, your positives one rail over, positive there, good, good. Negative on that side, yep. Now, just make sure that green wire is going to ground on your.
Yes, that one's going to ground.
Yeah, cool.
Then the orange is going to 5 volts.
All right, cool.
And this one's an 8.
And then the other side, that is perfecto mundo, exactly what you want.
Okay, cool. So now I just gotta work out the code. Thanks.
Yep.
Okay.
Okay, I don't know what went wrong, but it's not working.
All right.
I'm lost.
The Uno. I mean, what's not working? The LED is not turning on.
Correct.
Well, can you take a picture of it?
Yes.
Or if you, I don't know how your webcam's set up. You can always, if you have the phone app, you can join to the meeting that way.
Oh, I'll do that. Okay, here we go.
Okay, so that's on that side. Um, um, okay, so you're going to the ground there, that black wire. You don't have the ground. Okay, see, yeah, you got that backwards, if that makes sense.
What
Your
do I have
anode,
backwards?
well, you have that resistor going into um, 5 volts, not ground. Or is your black wire 5 volts? I can't tell.
The black wire is 5 volts.
Okay. So then the yellow wire coming back there, that's going to the ground, that's going to the ground, he's going to the ground. Digital pin 8. All right. What you can do just to try it out is take the anode end of the LED, that yellow cable that goes all the way to digital pin 8, and then plug it right into 5 volts somewhere. Yeah.
Another 5 volts, like right in
Sure.
the same one as here.
Well, there should be like 2 there. Let's see here. There's 5 volts on that side, and there's that's it. Now you can just plug it in the 3.3.
Okay.
Okay, so something wrong with the LED there. So I think that resistor looks a little well, he's even better. Take that yellow cable, just plugged into 3.3, and then plug it into that 5 volt rail down. The same rail as a black wire. Does that make sense?
Can I plug them both in?
No.
So just take out the black one?
Yeah, you can. Yeah, we're just testing that circuit, that part of the circuit. Seeing if that doesn't turn on, you know where the problem is. The problem there is that resistor, it looks pretty, I don't want to say beat up, but I don't think it's in all the way.
Oh, okay. Oops.
Yeah. If you want to set your phone down, that's cool, because that should turn on right there.
They need to give us mini hands for this or something.
Well, you do have those little tools, so don't forget you can use your tools.
Oh yeah.
Yeah, I just had to use my pliers to take out one of my wires got stuck. So do you think I need a new resistor?
No, I think it's the LED.
Oh,
Or
okay.
it's just it's just the connections. No, not that way. You have it the other way.
Okay. Yeah.
You had it the
Okay.
right way.
I don't understand how the map function. I don't understand.
How it works.
Yeah.
Yeah. Michaela, that's backwards. You want to throw it the other way, right?
Man. Oh, there
Yeah,
we
there-
go.
Yeah, so it's your LED. It probably got burned up because you probably hit 5 volts with it at one point. So there
Oh,
you go.
okay.
Ben, as far as the map function, that's why that on that link, look at the example that is online, and you do unfortunately have to take a few minutes and read through it. And,
I read through it, the thing.
Hmm.
Okay. Low, low, high, high. Okay, maybe I get this, but I don't understand. I don't.
Yeah, the bridge there, if you will, or the the thing we have to get over is, yes, we have to understand what all those functional arguments are, like the actual value, the from value low, and then the to value low, and then the from value high to the to the high value high. We have to understand how that works. Putting in there piece of the puzzle, then it's like, well, how do I use those? Like, what numbers do I put in there, right? And that's where it's like, I don't want to give you the answer, because then it's kind of like, oh, you would just look at it and be like, okay, yeah, that makes sense. Where I want you to work through it.
Okay.
So, work at it, keep working at it. I mean, we have 7 more minutes, but like I said, this isn't something I didn't anticipate us to get done with the whole lab today in class. And that's why we're just going to take an extra week. So that way, you, I, me, whomever, all of us individually we can work together. Or really, we'll have class next week. I probably won't introduce anything new. So at least by next week, and we should probably start wrapping up here, just so you guys can sanitize your stations, and we can get to your next class. But at any rate, yeah, I think this is probably a good point to start wrapping it up at any rate. So again, work through it, think about it, think about all the stuff that we talked about. I think, I think it's actually still recording. So there's a lot of dead space in the recording for today. Well, there's comments and stuff, which are good. But work through it on your own, definitely wire it up. And then just like we saw with Michaela, which I'm glad that we were able to do that in, just, break it down to its simplest form, which is like, hey, you know what? If I plug in an LED and I plug in a 220 ohm resistor in series and I give it 5 volts and I give it ground, it better turn on. So, and then build out from there, if that makes sense. So that's what, we can do all that with digital multimeter. That's the, that was one of the things we could have done, but testing LED is a little hard. But at any rate, the point is work through some of this and stuff and let me know what you have. Like take a picture of it. Say, hey, does this look right to you? I will make a video. I will, throw it in YouTube for you, send you a link, and I'll give you all kinds of information you don't want to know about.
Okay.
All right, so that's that. Like I said, for next week, we'll still take some time to work on this. So, again, I don't anticipate you probably got a lot of stuff to get around to get ready for our 2-week hiatus. So, take some time to do that. That does not mean, well, at any rate, that, just take some time to make sure you're ready. Get with me if you don't have the IDE. Devin just gave us this like really cool tool. I'm actually playing with it right now. And I'm going to wire up my circuit. And what I can do is I can make how you can set up from making something work virtually to making it actually work physically is pretty big. Just like what we saw, like you need like tools, like little fingers to get in there, right? So if we can get it working virtually, get our code working virtually, hey, that's great because then we know what we have to do physically. So I think this is a really powerful thing. I'm going to spend some time really quick now. And I'll make a supplemental video and I'll just put it up in stream for us and I'll give you a link.
Yeah, there's also examples in that software.
Yeah, I
Yeah,
see
an
the
LED
example.
one.
Yeah.
But it looks like you need to have a paid version because some of the components they use in the examples you don't have in the free one.
Okay. I saw that you basically need another microcontroller to interface with it so you can do all this. So I don't know if I'm gonna be able to do it right, like right now. But it's something that I definitely want to add. I'll look at it, but I'll buy it. I mean, from what I saw, the little extra microcontroller you need to make the jump from virtual to physical is like $10. So I don't know what else I need to buy, but I'll look into it. I'll let you guys know. Okay.
Cool beans.
So
You should
all right,
just
good
be able
deal.
to run all the virtual stuff just from the software.
Yeah, I'm gonna see what I can get away with free wise because I think at least some of these these first couple labs, we should be able to put it in there. So I will take a look and I'll let you guys know. I'll make a short video on it and then let me know what else you need as you're working. All right, guys.
Okay.
All right. So then, if I don't talk to you, well, I guess tomorrow we have class Friday. So I will see you tomorrow, bright and early at 11. And take it easy, and we'll talk to you guys later. All right.
Yep. See ya.